So who are you?
Hi, I'm Shobana Balakrishnan, and I'm a program manager in the Clusters File Systems and Storage group. I've been in this group for about 3 years. And prior to
Clusters
that,
File Systems?
Yeah, so CFS, it stands for CFS. It used to be called Core File Systems, but then we added the clusters, and storage has always been a part of file systems. So now we've changed the acronyms to mean Clusters File Systems and Storage.
Wow.
Yeah, and prior to this, I was in the driver quality group in the kernel group.
So you're smart.
I don't know.
We don't let. I can't work on the kernel.
It's fine, detailed work, and it's definitely challenging set of problems there. But
you're on the group that shipped our server, our 2003 R2, right?
Correct.
What does R2 stand for? Revision 2?
Yeah, Release 2 is what it stands for, and that seems to be the norm now. As a company, we've declared that we're releasing, main operating system main product roughly every 4 years, typically an operating system, and then kind of every 2 years we will release a minor release called a Release 2 with some well-needed features for our customers that have been asking for it that cannot wait till the 4-year release. So.
And you just had a meeting with all the customers, the TAP program?
Correct.
And so what did you show them last week? That was last week, right?
That was last week. That was the Longhorn TAP deployment summit.
This is early December, right?
Correct.
Mid-December now. So, yep.
TAP Summit, and these are customers interested in joining the Longhorn TAP program to give us early feedback and to start their deployments earlier than normal after release. So we have a lot of excited customers. Just to give you perspective, for R2, we also had this TAP program that we ran as a product group ourselves. We ran it within the Core File Systems group itself. And we had 20 TAP customers, excluding, of course, MSIT. Yeah. All over the world, you have Australian Ministry of Justice. We had Paul Smith from UK. We had Chevron, Texaco. We had all kinds of companies from all over the world participating, and they were all deployed at RTM. They've already deployed R2 in production, and that's what we accomplished with them. We worked through from beta 2.
What are the 3 coolest things about R2?
Oh, the 3 coolest things about R2, I'd say the first would be definitely DFS. DFS, especially with its new replication engine.
What is DFS?
DFS stands for Distributed File Systems. It's not a new name. It existed since Win2K, if you recall. Mm-hmm. DFS stands, as I said, Distributed File Systems. Earlier in Win2K, we released this term, and it meant, virtualization of a namespace. So if you want to have files actually stored on multiple servers, but you want to access them through a single name or single common name, DFS was the name used to access the files, and it would actually refer to the appropriate targets at which the files were located.
Right.
Alongside DFS, when we introduced it in Win2K, we introduced an engine called FRS, or File Replication Engine, which was kind of under the covers, hidden, not well exposed, and it could be used alongside with DFS to actually produce what's really called a distributed file system, where you have the namespace virtualized, as well as you have automatically synchronization of the targets, so that data can move and replicate between the targets using this engine called FRS. And that was the idea behind it, but FRS was not, as I said, well exposed, didn't scale very well to large scenarios, so it didn't get the type of deployment that we'd expected in Win2K and Win2K 3. So what we did with R2 is we completely rebranded DFS to be an umbrella term now. It means actually a distributed file system comprising of 2 components: the namespace component, which is the virtualization component of the share or location, and then the replication component, which is a totally new engine called DFS replication.
Right.
So these are the 2 components of DFS. The namespace component has been, let's say, enhanced.
Yep.
It's some new features. For example, I'll show you some if I can today: fail over and fail back, for example.
Okay.
And then the replication component, as I mentioned, is a total rewrite. It's a new code base. We started from scratch about 3.5 years ago, let's say at most 4 years ago from conception, saying, okay, what did FRS, first of all, what are the problems with FRS? What are our new customer needs? How can we build this state-of-the-art multi-master replication engine?
Right.
And that's what we built for R2.
Yeah. In the server world, I talk with a lot of ISVs and startups, people like Matt Mullenweg, who builds WordPress.com.
Right.
And he runs on a non-Windows operating system,
Correct.
Linux. And he and other people are asking me, what is Windows going to do to make servers easier to use, cheaper to use, and more performant and more secure than Linux? Right. Those are the four things I always hear when people are comparing Linux to Windows.
Right.
What are we going to do? Does R2 answer any of that?
R2 definitely does. R2 has for this feature called distributed file system that exists only on Windows boxes. Obviously, you cannot do. You can do the namespace aspect to a non-Windows box, but you cannot replicate to a non-Windows box or from a non-Windows box. So replication's out. So that's very neat in R2 and with Windows systems, server systems. The other thing is in R2 you have this file storage resource manager, which is a system for managing your file storage. On a single box, you can manage your quotas and assign per user quotas. You can do file screening, and you can get good reporting on how well your storage is being used.
Yeah.
And that's very useful to administrators. They've always wanted that and have asked for that time and again. So that's something that we offer that you can customize in your Linux by writing scripts, etc., to do what we talked about, but it's not in the box.
Yeah.
We also in R2 to make Linux and Windows operate together, because let's face it, in a data center you will have non-Windows platforms in large corporations.
Yeah. Over in Building 25 we have Sun Microsystems,
correct, or EMC, or NetApp, whatever.
Yeah.
So filers. So we have NFS, and we've now put NFS in the box in R2, or Network File Systems, which is the standard to interoperate between Unix systems. So we put NFS, which is Microsoft's version of NFS, in R2 as part of the operating system. So now you can basically have use NFS to serve and receive files from non-Windows servers back and forth, and all that's completely transparent in the box, and all the management tools to use NFS are also in the box. So that helps the interoperability issues. But the innovation obviously is going to come within the Windows file system, and that's where you're seeing things like, for now, DFS replication, and in Longhorn, transactional file systems, which I think you're probably aware of, and other innovations happening in the file systems will obviously be on Windows platforms.
Yeah.
So we'll do more innovation, for example, in replication from Longhorn, and those will be all for Windows systems.
Right.
For example,
you have a bunch of machines on your floor here. So you have a Windows Vista machine. That's a client machine there.
Correct. I have two client machines, and I was hoping to show you, and this is with the CTP build 5270. That's going to go out as a public release in December.
Okay.
And I was going to try to show you...
Any day now, right?
Yeah, it's actually scheduled for December 19th. Correct.
Not too many days left in December.
Correct. Any day now, before the holidays.
Yay.
Yes. So,
Christmas presents coming for the geeks.
Correct. And it's real, it's good. It's I'll wait for you to say how it looks. But
I've been using it. It's getting better every day.
It's getting better every day. I agree. In fact, I was brave enough to switch my main laptop over to Longhorn Vista builds, WinMain builds, because they're very good.
Yeah.
Office runs fine, and the basic operations all work very well.
Yeah.
So that's what I have there. I have 3 virtual servers.
After using it, I can't switch back to XP anymore, because the search. I like the search.
Oh yes, the search is so nice, native, built-in, and it's there everywhere, and it's the Longhorn desktop search is very good.
I haven't gotten Glass working on mine yet, but. Do you have Glass? I don't think you have Glass. No, I don't have Glass. No. Yeah.
Not yet.
They're still working on drivers for lots of these laptops. So.
Right. So I'll show you a cool scenario that we're doing in Vista with the same replication engine. Totally different scenario. But just to back off, in R2 the scenarios were twofold, 2 major scenarios. One was you have these large branch offices, enterprises with remote locations all over the world, geographically located, challenged because number one, they are low in IT staff, don't have IT. Typically, there's a secretary who can do some basic computer stuff, or basically nobody who's IT related. They have to be therefore managed remotely over pretty poor WAN links, some as low as even 64K, and satellite links with large latency, round trip latencies.
Yeah.
So that's the challenge. So basically the one major challenge customers had is, there's lots of data being created on these edge servers because there are information workers, knowledge workers of various types over there.
Yep.
And we want that data to be safe and backed up. So what do we do? If you've got to run that backup here, you need IT staff, literally, because to change tapes, etc., it just wasn't feasible. It was too expensive. So now with R2, we have the solution whereby you just use DFS with replication. You replicate the data over to the data center for collection, and that's called a collection scenario, where you can scale out to any number of branches. One hub, for example, can scale out to 256 branches very easily, and you can cascade. You can have multi-hubs and get a huge fan out. So with that, you have this hub and spoke topology where you're collecting from all the spokes to the hub. And that's a very common scenario, and then you totally eliminate backup from these edge locations, and then you back up your data center using enterprise-level backup solutions. So that's a key scenario. The second key scenario in R2 is, again, enterprises with edge servers being able to push out data, publish data. That's also often a challenge today. I mean, people do it with robocopy scripts or Xcopy scripts and various scripts. Some use some third-party replications. I'm sorry. Tone that down. Use some third-party replications. Tone the volume down, but anyway.
It'll go away.
And they're all, they're expensive. They're licensed, like, I think, per server or something like that. So there is no inbox easy solution for them today. And scripts are not, server class. So, they die, they fail, things don't happen as expected, etc. So with R2, again, we can achieve that scenario very easily. You have data out in your data center that you want to replicate out. For example, today in Microsoft, we have what's called Products Web, where we have a list of applications that people can install.
Yes.
Install
I
points.
use that to install.
Install points. And all those applications today are being replicated by DFS replication. So we have, all those applications. There's a bunch of them, like 200 odd high-level application folders. Each is a replicated folder.
What are the trends you're seeing in data centers? Are they going with a hub and spoke model, or are they going with more of a Google model where they're putting data centers around the world and shoving the data?
So they're
having multiple data centers with the same data, so that when you're hitting a website from Ireland, for instance, you get fast response times just as if you hit it here in the United States.
Yes. That is ultimately the model. There's some number of data centers, but a very small managed number around, strategically located around the world. Maybe 2 or 3. And then, from there they fan out as a hub and spoke. And then the data centers are well connected, and so that you can achieve, high availability and all that in the event. And even, and then sometimes the model is also where, if it's important for disaster recovery, you also have another data center close by, but at a different site for disaster recovery, so that if this data center goes down, the other data center comes up. But for just
that's really important in California because of the earthquakes.
Earthquakes, correct.
I mean, most of the data centers they say will survive. I got a tour down there, and they said they'll survive an 8 or 8.5, but I don't believe them.
That is
having lived through a 7.1.
Yes, I was there during the San Francisco earthquake.
Me too.
Okay, so but yes, it was scary.
So that for somebody who's building an enterprise class data system. That has to stay up. That's a scary scenario, right? If an entire region goes offline, nobody can get to your business.
And that's where DFS comes to play, because with DFS, your clients don't even know that a data center has gone down. The DFS client automatically then gets a new referral and refers you to the next available target. And I'll show you that if you have time, or I don't know how you want to do the format you want to do it.
Show me all the cool stuff.
Okay, cool. If that's the case, I don't know who this is, but I'm not looking at I should not. So I have here 3 virtual servers.
All right. And you're running Windows Server 2003.
R2 on each of these virtual servers.
Okay.
So let's just wait for a second for it to come up. Sorry. Let me explain the topology. I have a hub. You can see it says hub server, Shobana-hub. And that's my hub server. So I'm going to log in.
Okay.
Wrong password. I'm using my Longhorn.
I got yelled at for showing the keyboard string when somebody's entering its passwords.
So.
C/dot. I actually do read your comments.
I log into the client. So what I've got is I've got a hub server in Redmond.
Yeah.
And then I've got here a branch server which says London branch, LND-branch, okay?
Okay.
And I'm going to log in there also.
Is that really in London?
Yeah, it's in the site called London, and actually you can use a WAN simulator to simulate a WAN link. You have network simulators that do that, so we can use that. I don't have new enabled, but I've done that in the past in demos and actually shown a slow WAN link of like 256K or 512K, which is reasonably normal. 512 is a bit slow, but you do have it in Africa and Australia, etc.
Yeah.
So you can do that. I did not have it right now, but here. So these are my two servers, and then I have a client out here who's also connected in London to the London site.
Okay.
And I'm going to log on as a user, virtual server, as Chris Green, okay?
Yep.
And domain is a fictitious company called controso.com.
Right.
That has been set up. So my hub server is also a domain controller. The first thing I'm going to do is now set up DFS, like we talked about. So I'm going to go ahead, do my DFS management.
So
this
you
is the new
clicked on DFS
management.
Yep.
Yes, this is the new UI, which is based on MMC 3.0, that ships in R2. It's taking a little while. I shouldn't be. It's the virtual server. Oh, it just took too long. It was coming up. I just was impatient.
Yep.
And I have a camera staring at me behind my back.
It always goes slower when channel lines
I get a
watching.
little impatient.
Yeah.
And these are virtual servers, as you recall. So I'm not memory constrained. I can leave, for example, I'm sure all of you have checked out the virtual server management UI.
Yep.
And you can look at your utilizations, etc. I have several virtual servers, but only 3 of them are on right now. So I should be good on this machine, this host machine.
We interviewed that team. They're
Okay,
really interesting.
so going back to this UI,
Yep.
this is the new UI that I was talking about, where we've made namespace and replication for first-class citizens under DFS.
Yeah.
Completely integrated. So what I'll do is and you have a start page that kind of gives you an overview of what is namespace. All this is based on MMC 3.0, so it's typical of the actions at this sidebar, etc. So I'm going to start off with creating a new namespace, and I'm going to create a new namespace on this server, the hub server.
Yep.
And I'm going to call the namespace users. I'm going to create a domain-based namespace. The advantage of domain-based is, you're using your Active Directory infrastructure to store your configuration for the namespace.
Right.
And therefore, you have a permanent store of it, and it's always available. So with a standalone namespace, you're storing your configuration actually in registry.
Okay.
So it's therefore, a standalone as one point of failure. If you don't want that, you'd go for the better fault tolerance, you go for the domain-based namespace. Although with standalone namespace, you achieve better scalability. You can go to 50,000 links as opposed to 5,000. So let's create a domain-based namespace. Go ahead and create that. Close. So now I've already got my namespace created, and I'm going to add some targets. And these are what are called folders in the new terminology. If you're familiar with the Win2K terminology, it used to be called targets. So now we're calling it folders.
Okay.
And I'm creating a folder called user data for my users, and I'm going to add a couple of targets. The first target I'm going to add is on the hub, and I'll just use a already created share called home drive for it, to store the data, okay? And then I'm going to add another target, and this one is going to be on the branch. I'm going to browse. Okay, sorry. Why didn't it work? London. Oh, it's a dash. Yeah. And
So you can't use underlines?
No. So I've got the two targets now created.
Yep.
As you can see, and it asks me now, do you want to set up replication between those two targets? And I say, oh yes, that'll be nice. So it just automatically goes ahead and creates your application. You can click through the names, etc. But we've chosen some good default names. and it's done. It asks you who the primary member is. Now, in my case, I'm collecting data from the London branch. So the data is being authored in London by users like Chris Green, and it's going to be collected over into Redmond, my hub. So I'm going to say that initially when I start off replication, I want whatever data that exists in London to be the primary. So and what that means is that when London and Redmond sync up, this data is considered authoritative. So if for some reason there was conflicting data here, this data in London would actually win, and it would be it would be the one that would ultimately end up on both servers.
Okay.
So that's for initial replication. So for initial sync, it asks you who you want to select as a primary, and I'll say the London branch. And then I'm asking what kind of topology. We are very general purpose replicator. You can select and connect your computers in whichever fashion you want. For example, you're asking me what's a popular topology. One would be like a multi-tiered hub and spoke.
Yeah.
That's what, for example, MSIT uses for the products web. They don't distribute their data just from Redmond all over the world. They go from Redmond to, let's say, Munich, which is a tiered hub.
Yeah.
And from Munich, they distribute it out to Europe. Then similarly, from Redmond, they go out to Sydney, and from Sydney, they distribute it out to those parts of the world, etc. So they do the multi-tiered replication, and there's reasons, historic, whatever, network related reasons for doing
Probably
that.
have high bandwidth taps between those locations.
Right. So that's you can select and create whatever topology you want. For our purposes, we'll just go with the full mesh. You can also select how you want to use your bandwidth. Yeah. Do you want to use your full bandwidth, or do you want to throttle it? You can throttle it to a value less than the full bandwidth. And you can also not just throttle it, you can edit how you want to throttle it through a schedule. Let's say you can say I want 64 kilobits at all times, and in this time I want let's say 2 megabits or something like that.
Right.
So
during the middle of the day you're going to have busier traffic.
Correct. So you can do all the...
At 2 in the morning nobody's using...
Correct. You can be flexible enough to do...
All my friends in London are downloading videos. But
yeah, right. So you can be flexible enough to do that. So you just a couple of clicks and you're done creating your application group and folder. So at this point, we're done creating. What it does is the UI stores all this information in Active Directory again for a DFS replication. And DFS replication running on each server, the hub and the London's branch, polls Active Directory periodically to pick up new configuration changes. Okay. And
by the way, on the limiting on the bandwidth, is there any way to watch for bandwidth utilization of the system and then say, hey, if there's no bandwidth being used, nobody's using the internet right now, can you throttle it up, or can you throttle it down if you notice that all of a sudden a server got real popular?
We don't have a very proactive way, but we do have a way which is kind of indirect, and I'll show you that. So after we've done some replication over a period of time, you can run what's called a health report that will tell you, how many files were transferred, how many bytes were transferred across the wire, how much bandwidth was used, how much bandwidth was saved, etc. Now, if you find that your bandwidth consumption is too much, or then you can reactively throttle it down based on the health report. Right. But proactively, there's no continuous kind of monitoring whereby you're monitoring on the wire how much bandwidth's going out, and if it's not if it's too much, throttle it down or throttle it up automatically. We haven't come to that as yet, but there will be a time when that will happen, where there's more support in the networking layer, which is happening in Longhorn actually.
Yeah.
So
where do you see people making mistakes in their topology?
Mistakes in topology. First of all, I see people making mistakes in having, let's say, some disconnected topology. They could have, for example, a topology where you have, let's say, in this case, some people want, let's say, a unidirectional, a topology of hub and spoke. And remember, each of our connections is unidirectional, so we create 2 connections actually, one going this way and one going the other way.
Yeah.
And they could bring up a server, new server or whatever, but not connected to the topology. So it's at this point a disconnected set of nodes. So, and we do a very good job in the UI. We detect such disconnected cases and we flag the user immediately. So that shouldn't be a problem moving forward with this new UI.
Right.
That's one case. The other case would be when you set up everything, but then somehow you've not initialized a primary. that would be a situation where everybody is now waiting to see who can start off this initial sync. And only typically a primary is the one which will start off the initial sync, and then other nodes will start syncing from the primary.
Right.
But if that doesn't happen, you'll just be waiting endlessly, and that's just a config type of error, configuration error.
Right.
How people make mistakes in topology, typically, the topology, if when you start deleting servers, we do a good job of cleaning up all the associated Active Directory objects in AD. So you shouldn't have any stray or lingering objects. But in the past, we've had, for example, some issues there. And I've seen, or people have done their own cleanup. They're going to manually use ADSI edit or something and cleaned up some objects and left some backlinks hanging, and that can cause problems.
Right.
So that can result in a bad configuration. And again, we flagged those also with DFS replication.
What kinds of things do you worry about the developers who build apps on top?
Yeah.
And what kinds of things do they need to
Very
know
interesting.
about?
Very good question.
Because I know, again, back to WordPress, he built a blog system that was meant to have extreme scaling,
Right.
because he's going to be able to put my blog post on one of 4,000 machines. And he's really thought about scale because he
Correct.
knows that the number of blogs doubles and every 5 months, and the number of users goes up even faster, particularly if you get popular.
Right. So first of all, regarding scale, we are meant to scale very well because, as I said, each hub can support a fan out of about, let's say, 256 connections.
Okay.
And this is assuming all 256 are active at the very same time, pulling and pushing data in and out, that's with the stress scenario.
Is that the 64-bit version or the 32-bit version?
Both the 32 and the 64 can support.
Okay.
The 64 will probably go beyond that.
Okay.
But that doesn't mean that you can't support more than that. Number one, as I said, you can have multiple bridgeheads or multiple such hubs connected in the data center through some high-speed connections, and then these in turn can fan out to any number, so you can globally have a very large topology, and each node does not have to know about the entire global topology. In fact, it doesn't know about the global topology. Yeah. All it knows is about who it's connected to, and that's all it needs to worry about and care about.
Right.
So there's therefore no issue of reaching a bound of any kind, because you're only going to be worried about how many you're connected to, and that could be a large number, like 256 for a hub. But again, you can cascade any number of hubs and get a huge topology.
Right.
So that's with respect to scale. We do. I have not mentioned this, but we have a very efficient algorithm called remote differential compression (RDC). That is a brand new algorithm shipping first time in R2.
Okay.
Part of DFS replication, and this is a very cool technology, interesting technology. What it does is it allows you to, given a client-server model, so let's say this is a server, and I'll call this a client because it's receiving files, okay?
Okay.
So it's actually a server, but in the SKU terminology, but it's the one receiving files. So given a client-server model, what RDC allows you to do is to send, let's say you have a file foo, and then you make changes to the file, okay? So this is foo, and then this is a new version of foo new, okay?
Yeah.
You make changes to the file. So irrespective of what version you have on the client, you could have had foo from this version or some very old version even before. So irrespective of what version you have on the client, with RDC, it's a protocol whereby the client and server figure out that they have some common files that they can use. So what they do is they chunk up the file, get hashes for the file, figure out which hashes have changed, and RDC is then able to only send the changed portions of the file foo over the wire. So it's the changed chunks that actually go over the wire. And this is a simple case where you've got a same name file on the other side. Yep. Imagine the other case where you've just got another file, let's say bar, totally new file, different name, different location, even in the file tree. Yep. So one could be at let's say root users bar, and the other could be root Chris Green foo. Yep. But let's say these files have something similar. We have a heuristic algorithm called cross-file RDC that uses a technique that is used in web pages called similarity. So based on these RDC hashes, we calculate similarity traits of the file, and we reduce it down to a 16-byte value. And with the similarity traits, we are able to tell in our entire volume that we are looking at or replicating what are good candidates for RDC, what files are similar to the file foo that I need to replicate in. And if there are good candidates, we select those to be candidates for RDC. So we then take out common chunks from those files and reassemble or recreate this new file bar using chunks from existing files that have some things in common. So let's say you had a PowerPoint presentation, you did a save as, and I'll show that to you in a minute. You do a save as, it's a new file altogether, but it's common because it's got similar elements.
Yep.
We are able to extract that out from the existing file, so we don't have to send it across the wire. We only send the changed chunks across. So that is something very neat and new that doesn't exist anywhere else in the open source.
I'm starting to get why the Office team is so excited about XML, because that algorithm probably can work even more efficiently on an XML file, right?
Correct. It works, and we've seen, for example, it works and it's agnostic to the type of file. We don't know how it's created. We don't know the format of the file. We have no idea. We can do smarter things if we knew, but even now, without knowing, we just chunk up the file, and the smarts is in how we chunk up that file. We try to keep chunk boundaries the same so that as many chunks don't change, and only the chunks that change can be identified in the narrowest possible scope.
Interesting.
Okay, so that's what I'll show you. If you would like, I'll show you that in a minute.
One other thing, on Longhorn Server, because we haven't talked yet about what's coming out.
Right.
When is Longhorn Server coming out? So sometime a year, 2 years, 3 years down the road?
So at this point, we can't say, but I think it's in 2007.
Okay.
That's a given. When in 2007 is hard to say.
Yeah.
And it's going to be a major release of Longhorn. So basically, there are lots of new things in Longhorn Server, other areas. But
now, are you getting the new networking stack that they built for Windows Vista as well?
Yes.
And that's right. I just interviewed the Microsoft.com folks, and they said they're seeing huge improvements, in, especially in their gigabit networks, because they can tap out the gigabit networks on Longhorn Server.
Correct.
Is that what you're seeing too?
We have not come to a point where we're measuring network performance, because we're right now just testing functionality and getting past feature complete, which is very, very soon now. So, but yes, we have seen that from brief experimentation. We will be doing more of that testing in the coming months.
That's really exciting.
That is very exciting.
We interviewed the networking team, and they're very excited about their new networking stack. And they said they're seeing huge improvements just on the client, on Windows Vista.
Correct.
Between like here and Silicon Valley.
Yes.
They said they saw up to 40 times the performance.
And to give you an example for how RDC does, for example, for the MSIT products web data, we get like the 80% savings in bandwidth. So, and I can show you graphs on that, but basically just using RDC, because what we're doing is now we're replicating only the changed portions of files.
Wow.
So let's say you put out Office in 10 languages.
Yeah.
You don't have to replicate all those files, because at most the strings are changing in one file here, one file there. And those changed portions of files is all you replicate, and we're able to do that. Therefore, the MSIT has seen over 80% savings in bandwidth with RDC.
Our that saves us a lot of money, huh?
Yes, that saves. Our TAP customers have also been saying the same thing, so they're all very pleased with that. So what's coming? You asked about Longhorn. The basic replication engine was V1, shipping in R2. With Longhorn, obviously, it's V2, so it has new features, new cool features. There's a new feature called what I'll call ghosting. The technical or the marketing name is going to be called on-demand replication, but internally we call it as ghosting. And what that feature means is that you replicate only your metadata to your locations. In other words, your file names, your attributes, your sizes, your alternate streams, not your main data stream. And then, based on user demand, you fill that data as they request it, or as they make reads on the file. So let's say you've got this whole huge application directory that you can replicate it out very quickly, because you're only replicating out metadata. And then a user in Ireland will install, let's say a user in Japan will install the Japanese version of the OS. And that time, you just, as they double click on the file in real time, in the kernel, we have a driver that actually captures that I/O and goes up and talks to the service up the DFS replication service. The replication service talks to its partner on the other side and pulls the data as efficiently as possible with RDC over here and then sends it back fills the I/O call back to the driver and to the user. So the user starts reading the data live, and it's coming, and it's basically streamed over the WAN. And you can do that, for movie files. As they watch the movie, only those files get filled, and otherwise you don't waste space, you don't waste bandwidth, and so it's basically a real cache in that because it keeps the hot data locally available on the server, and any cold data that's not being used will get automatically purged back into this ghosted form over time. So your data is still, manageable. It's only the hot content, and only the content that is really needed goes over the WAN. So that's this new feature called on-demand replication or ghosting. And you can save tons of storage space. Storage is cheap, as you know, but IT admins still struggle with storage.
Yeah.
I mean,
it still costs something,
Yeah. MSIT is still running into storage issues and space issues on every single server.
That's because of me. This little camcorder does.
And they use this very cool feature, by the way, that I don't know if you've heard of, which is coming out in R2, Windows Storage Server R2, called single instancing, SIS, single instance store.
What does that do?
That basically does, if I have multiple copies of a file situated on the volume, it basically says, oh, these are all the same file. So I'm going to single instance it. I'm going to keep one master copy and a database, and I'm going to have reparse points or pointers to these files. So every time I'm accessing the file, I'm actually accessing it through the pointer on the master copy. Now, if I change that file, then I know that 3 of these files are still the same as this master copy, but then it makes a copy of the file because it's being written to, and then it removes it from the single instance store because it's no longer a single instance.
Right.
But if there are basically multiple copies of read-only type data which are not changing, for example, OS installations are a typical example, or application installs, any type of publication data, multiple copies, think about it, how many, you have multiple copies of the same file on your disk, on a laptop even, because you do different saves. Then a single instancing is able to very efficiently instance it only and create only one copy of that file on the volume. So you save like 4x the amount of space or 3x the amount of space. So that's the cool thing about single instancing, and that's also coming with Storage Server R2, which is along early part of 2006.
Okay.
So
there's still another R2 coming.
So that's the store. If you remember, there are SKUs. This is the general Windows Server SKU that was just released, RTM. It's called Windows Server R2.
Yep.
And then there'll be a Windows Storage Server, which is the NAS version.
How do you know you need the storage server? What kinds of customers need that?
That's a good question. So customers who want a general purpose server will go for the Windows Server R2. You can do general purpose, including file serving, but not limited to file serving. While if you want just basically your file serving capabilities, and that's all you need, you just want a file server, you want fast tuned for file serving performance, then you go for the Windows Storage Server.
Got it.
Okay, so and then as I said, it has some of these cool storage management features like single instancing, in addition to all that already exists on Storage Server for storage on Windows Server for storage.
Right.
Okay, so that's
cool. Well, let's see some more.
Let's go back to demo.
More toys.
So I wanted to show you the demo, which was, so we just set up our application. Okay.
You practice good security here.
Okay, so here's my application. So I'm going to now go as Chris Green to my client. Okay. And I'm going to, first of all, open a PowerPoint. Before I do that, I also want to go to my hub server, which is here, and I'm going to open up perfmon, the famous perfmon. Perfmon. Should have known how to type. Okay. I'm sorry. I'll just go delete all this stuff because I don't want it. Okay, and then I'm going to add some counter. I'm going to add some counters to look at some statistics. Okay. So I'm going to add on the hub server. I'm going to add a counter, and we've got a bunch of performance counters, but I'm going to add DFS replicated folders. I'm sorry, Did I do replicate folders? Yeah. RDC bytes received and RDC size of files received. So what these two counters mean, bytes received and size of files. So what these bytes received is actually what bytes are actually sent over the wire using RDC.
Right.
This algorithm that I talked about. And size of files received tells you what is the size of the actual file that would have been sent if you didn't use RDC.
Yes.
The full file size, basically.
Yeah.
So let's do a comparison of those two. And then I close, okay? So I'm just going to, so I've got these two counters here.
Yeah.
And
we're watching.
And we're watching. And then I'm going to go over to my client,
Okay.
which is here. Sorry, wrong one. Client. And I'm going to make some changes. First of all, I'm going to replicate this file as is. It hasn't yet been put into the replication folder.
Yep.
So I'm going to do a save as. And I've mapped my replication. It was on my desktop. I've mapped it to my H drive, just like normal companies would do. So I'm going to save it here as a draft.
Okay.
And you'll see that if I go back to my London, my hub machine, you'll see that RDC was not used at all. Because the first time that file is brand new, there's no other data available on this side to even remotely match it in any way, because I'm starting from a clean system. So there was no RDC. The file had to just be transferred normally. And if you want to see that the file was transferred normally, let's go to thought I'd put it here, but home drive. I don't remember what I call it. Okay, there's the file, and it's about how many? 1.1 megs, right?
Yep.
So that's the file, and it's been replicated. So over to Redmond.
Yep.
Now I'm going to make a small change back in London as Chris Green. I'm Chris Green working on this presentation, let's say. So it's not Drew, it's me, Chris Green. And, you know, everything is good so far, but all said and done, you know, there's this thing, this supports, this is based on MMC 3.0. So make a small change there.
Right.
And I'm going to do a save.
Yep.
Now you'll see this is a normal save, no cross-file RDC because the same file name. But let's see what happens. Go over to Redmond again.
Yep.
And there you go. There's your perf counter.
Yep.
And I should have
Change the
changed
color.
the graph and the color, both of them. So let's say this was like that's too big. Okay. Okay. So this is way done. Make this better. I'll change the color on it, but the graph looks horrible. So here's an idea of what happened. So the bytes received by RDC was 28K.
Yeah.
And the actual file size, as you saw, was like 1.1 megs. But we only transferred like 28K across the wire.
That's great.
Because of the small just a small change we made. That's all that we needed to transfer, some amount of metadata and the actual chunks that were changed. And you saw the change I made was not just at the beginning or at the end. It was right in the middle of the file. And it's able to still pick up only that chunk that has changed and send it out.
Oh, that's really great.
And if, in contrast, I mean, there are some other chunking algorithms that exist in open source. For example, there's rsync that does chunking, but they do chunking differently. And you know, there are several they basically used fixed-sized chunks on the server, and then they make the server do the check and compare it with the chunks on the client based on a rolling hash mechanism. And we've compared RDC, for example, with rsync. We've optimized it quite well, and therefore we do better than rsync in general, you know, Office type files. We've tried, and as I said, we're completely agnostic to the type of file. So it could be Office, it could be VHDs, you know, virtual server images, it could be EXEs of any kind. So, and we still do well. That's RDC. Then we can do something more, you know,
That's really cool.
more interesting. which I talked about, alluded to, called cross-file RDC, or the similarity. And that basically says, okay, so I don't think I want the feedback slide. I'm going to add some new slides here. So let's say at this point, this is just
We only have a couple minutes left.
placeholder. So I'll just show you the cross-file similarity also.
Yep.
I added a placeholder here. And I'm going to do a save as to a totally new name.
Okay.
Okay? And you're going to say, okay, so this is not a draft. This is called new.ppt. And I'm going to save it to my London. It goes, as you see, it's mapped to my London branch. Okay? And I'm going to do save. And then I'm going to go to my hub server here.
Yep.
And there you see, instead of the 2.2 megs now, we only transferred like 84K altogether over the wire.
That's amazing.
That's amazing, and it's a new file altogether. It could be anywhere else.
And this is only with Server R2.
This is only with Server R2. This new feature called Similarity or Cross-File RDC requires one end of the connection to be enterprise server. So we have introduced this Q feature differentiator.
Okay.
It's not a technical limitation, but it's a Q differentiator basically.
Got it.
So that's that. I could show you the failover if you're willing to do that, or would you want to see Vista? Which one do you want to see?
Vista.
Okay. because you're okay. Now I will. So I've got here two Vista clients. I'm logging in with my my domain credentials.
Okay.
Sorry, I have to go back and forth.
No problem. So you have two Vista clients
Yes.
here, right? These are not servers.
These are laptops running client. And the cool thing is this replication engine is a programmable API. And here's an example of Shell, Windows Shell, using the replication engine and its APIs to actually do a totally new scenario, which is keeping PCs in sync.
Okay.
So it's called PC-to-PC synchronization.
Okay.
It just keeps peer-to-peer. It configures them, not an Active Directory or anything like that. Configures them through its WMI API. We have a full-fledged WMI. And you asked about programmers. We have a full-fledged WMI model available to program DFSR. It's documented on MSDN. I can give you links later if you'd like. But it helps, programmers can, use it as we are doing in Vista Client here. Shell is doing in Vista Client.
So how did you set these up? What do you?
I'm telling you. So all.
Okay.
Oh, okay. So I'm sorry. All they have is at this point they're just running Vista.
Yep.
Windows. What the heck, Defender? Okay, fine. We have new features everywhere in Vista.
Yeah. So Defender's giving you
trouble. Okay. Permit. Okay, there's a driver problem issue, but anyway, so here I'm going to do is I'm going to set up what's called PC-to-PC sync.
Okay.
And it's available natively in the shell. So if I do documents and it says to sync with other PCs.
Okay.
I do right click, okay?
Yep.
You should see this in your beta too.
Okay. So this is coming next year.
No. This December release, the CTP.
Oh, this is on the CTP.
Yeah.
Okay, I'm sorry.
It's already there in the builds, and it's so it tells you a little bit of PC-to-PC sync. You have to opt in. Then it asks you who do you want to
sync with.
Yeah. I believe it's that name, but I could be wrong. Okay. So okay.
PC sync.
Let me double check the name on this machine. I changed the name just before you came. So, because I was having some domain issues. Shobana Balakrishnan, yeah. So yeah, this is my machine. Why isn't that sync? This is this build was not working as I expected it. So this should have normally finished, and it should have just set up. This is Shell configuring DFSR through WMI and configuring these two machines to say they're part of a replication group, just like we did in that big MMC UI. But here it's all under the covers, not exposed. And the topologies, it's a full mesh. And basically these two are configured. It should not be taking that long. So I don't know what's blocking. The only thing I can think of that might we have created exceptions to go through the firewall, etc. And we have a registered port to communicate on. By the way, we use RPC for communication, so we have registered port with IANA. one thing I know that could have happened, this is the bug that was supposed to be fixed, was that the manifest where we shell punches a firewall exception.
Yep.
That they were using a new rule, so yeah, we are unable to connect. It's probably because of the firewall exception not working as it should have. So
Okay.
I can set that up in a minute if you have time. But basically the scenario would be these two would have connected, and now my documents are always going to be in sync. So I can take this laptop, make mods, come back, as long as I'm connected to the network.
That's going to be killer.
The other one has it. This could be my desktop, for example. This could be my laptop in a domain.
And everything, my Outlook files, everything will be synced.
No, let me be clear. So
Okay.
it's 6 known folders. So it's your document, all your documents, your pictures,
But if I put my
your music.
PST in
Yes.
the docs, it'll sync it over.
Yeah. Mm-hmm.
Awesome.
Awesome. Yeah. That'll be killer. That's.
I'm gonna go try that right now.
I wanted to show you the only thing. Let me turn off. I want to try once more, because this. How do I turn this off?
It doesn't let you turn off the firewall.
I can't believe that. Then let me turn it off. No. Okay. This is weird.
We don't want you to get viruses.
Yeah, it's just no. So as I said, this was a small an issue that I was hoping was fixed in this build, and I was intending to set it up before.
No problem.
But this should work in your CTP. It's a killer scenario. There's another cool scenario
I'll try it on my
that
desk.
also works in CTP, which is this Windows collaboration. So just to give you a flavor for what applications can take advantage of DFSR. This is another cool application called Windows Collaboration, which is something like lets you set up a meeting, virtual meeting between users.
Yeah.
Or located within a network,
Yeah.
using the peer-to-peer infrastructure. So it uses the peer-to-peer graphing to compute a peer-to-peer graph between users, and sends meeting invitations. And if they all accept, they're all part of this graph. And you can then send information back and forth with nodes in the graph, and the nodes can be arbitrarily connected in the peer-to-peer topology. And if one node disappears, one person drops off the meeting, it automatically connects the other guy so that they're all still connected, and keeps the meeting, the connections, basically keeps a connected topology. That's all peer-to-peer doing. And basically underneath they call us, DFSR, to be able to replicate data for this in this meeting scope. So a folder is set up for the meeting, and any data that you want for all meeting attendees is replicated and available through this app.
Yeah.
So that also should work in the in this release. I don't know if I have time to show you.
No, I gotta.
If it'll work. But this is just to give you a sample of the types of applications you can use with the replicator.
This is great. We'll come back and get a more complete demo and maybe tomorrow's build will fix this.
Yes, in fact, I would like that.
I'm using Windows Vista too, and every day something new fixes and something.
This was a late-breaking change. It happened only yesterday, so I apologize for that. But yeah,
no
we will get it, and if we can get.
This is a realistic scenario of what it's like to work at Microsoft on pre-beta software.
Pre-beta, that's right. And yeah, but these are some cool examples of where DFSR is going in Longhorn Vista. In Longhorn Server, there are other applications scenarios such as supporting, high availability clustered file systems, supporting this ghosting that I talked about, metadata only, replicating metadata only to save bandwidth and space,
Well, thank you very much.
etc. So yeah, you're most welcome.
Thanks
Thank
for
you.
spending an hour with me, and we'll come back and get more in depth on the failover and the Windows Vista.
Absolutely, and I will get this running so we can get.
You'll go yell at some devs.
No.
Fix this bug.
Yeah, the promise is not in our control, as you said, and it happened in a manifest somewhere outside our scope. So, but it has been fixed, so I just have to track it down.
Thank you very much.
Thank you. Bye.